Hello, good afternoon. I'm the president and founder of NanoXSolar NXS Technologies Inc. We're here today to talk about customer development interviews and technical guidance for the future of photovoltaics and energy storage systems, and also the integrated compatibility of inverters and kind of a case use of identifying the development needs behind these product developments, recognizing some of the risk industry changes that need to take place. We're looking at overcoming some of the delays in technical scope of work and blocks for interconnect and construction projects. That way, these are fundamentally helping to break ground on C&I and the development of residential power purchase agreements. How are you today, Eric? And thanks for
Good.
joining us.
Yeah, no, thanks for reaching out, and I appreciate to shed some light on some of these subjects.
Yeah, I wanted to invite you in for a quorum to get your professional review feedback on energy as a service, as an infrastructure. And we see that grid resilience is actually an environmental issue, looking at climate change and the impact of EMSG goals across all industries.
Mhm. Yeah, uh, yeah,
So what are
definitely.
the environmental risks that are most concerning for your solar installations, and how do you evaluate the panel durability and things as a vendor selection?
So, with my background, Jonathan, obviously I've talked to many construction companies, developers, EPCs, and obviously, one of the easiest things for them is they want products that are pretty much reliable, especially in the case where you're doing PPAs like you've been talking about. I think reliability is huge. So when selecting different vendors, you want to look for vendors that have been in the game here. We've been in, what established companies that have products that have been in the game for a while, and that also have a great service and engineering team backing them.
Have you ever experienced any hail damage in the field before?
So I've heard of it. It is a an issue. But with my experience, mostly with inverters and more recently energy storage systems, that's not something that I have an expertise with. But I do know that it can be a heartburn for a lot of the people, the workers installing the system.
Yeah, on the electrical side, what kind of specs or certifications are customers looking for?
As far as our inverters,
Inverters primarily,
yeah,
because it's the
inverters,
safety
yeah,
disconnect between the photovoltaic system.
yeah, obviously UL 3741, UL 1741. I think it's important that your company um, has established applications engineers and product designers on staff, that where your products are constantly keeping up to date with the electrical code standards, NEC codes, to make sure that they are all approved and the newest and the latest and the greatest.
On sourcing and RMA issues, in the event of these technical challenges of sourcing products from overseas from manufacturers, especially regarding the product specs and warranty claims, have you had customers that had RMA issues or spec mismatches in the field?
With my experience at CPS, no, I think we haven't had issues like that. I think our RMA process. You want me to go into kind of what our RMA process was at CPS?
Yeah,
That
like
help you?
if you
Sure.
guys, verify product claims and things like that, if a
Sure.
customer was to encounter an issue in the field.
Yeah. So one nice thing about CPS Chimp Power Systems is we have a separable wire box. So you have your wire box and then you have your power head. And if you have a power head, normally if there's a failure, it'll be in the power head. The RMA process is simple. You give us a call, we can remote in and look at it. If we deem that it does need to be RMA'd, there's 4 bolts that you pop off. Anyone pretty much in the field can do it. Obviously, you shut the power off first. But you don't have to be a licensed electrician to go out there. So it saves a lot of money on O&M with truck rolls. But our process is you call us in, we ship another power head out within 24 hours. Once you get it, you pop it on, put the other one back in the box of the unit that we shipped to you, and you send it back to us. So pretty simple process that gets you back up and running pretty quickly.
So the customer would encounter just a few monetary delays during the shipping that back and then return delivery.
Right. And we actually even pay a little bit. I don't know exactly what the number is, but we do give a little bit back to the company that pops it off and pops it on to us, to the owner of the operation.
For a system design decision, do you include a DC breaker between your solar panels and your inverters for your PPA design?
It depends on what your it depends on the system size, and it also depends on usually there is a breaker installed in there, but I would say sometimes if you're using, we have, again, depending on the size of the system, on our larger systems, if you're designing with are you talking about C&I, like utility scale stuff?
Utility scale, yeah, is primarily what we're seeing in the field.
Okay, because you had,
Like the whys and why not to, putting these breakers in.
yeah, safe. I think safety is everything, right? I mean, I think you want to be as safe as possible. CPS, we designed with our 250 kW inverter and our 350 kW inverter. We also designed the balance of systems, which is the breaker box and the switch box, which is all incorporated into the design as well. So we actually, for the 800-volt products, we manufacture those in-house, so we can provide a full solution for the customer. With the 600-volt products, they're a lot more readily available. Our inverters work with all of the major players in that game. So that's us. The reason we manufactured the 800-volt ourselves was because there's not a lot of that out there yet here in the US. So we actually manufactured that ourselves and was able to provide the client a full system with the inverter, the breaker box, and the switch box.
And what are the safety or cost trade-offs, with deploying a DC breaker between the inverter and panels?
Say that again?
What is the actual safety and the cost trade-off with customers saying they don't want to have the actual breaker box installed or actual ARC box as a safety tolerant system in the MC4 connection?
So we've done a lot of, I did a lot of 5 megawatt community solar projects where those were required by the utility. So I don't know if it's much a cost thing, but when you're designing with those types of products, there had to be something they were required on the drawings.
Okay.
And
That's interesting because I guess the utility or the AHJ having the jurisdiction, they wanted that as a safety mechanism.
And that can vary. I'm talking specifically about New York, the New York market. That may be different state to state. Some states are on different electric codes. So it all depends on having the right designer, the right engineering company do the drawings for you as well.
Yeah, and looking at Yeah, looking at those arc box solutions, it looks like, it was a standard into the BOM for the bill of materials to be delivered as a fire safety enhancement. And you absorb
I've
that.
actually never heard that term, arc box. What
Uh,
can you?
yeah, I'll be happy. The connector. So whenever you're bridging your two connectors together, you put a ceramic box that it prevents the fire runaway, the
Right.
thermal runaway.
Thermal runaway. Okay.
And when you look at this added cost and building out these community-based solar and C&I projects, would you absorb the cost into your PPA cost model today if you're building these out cradle to grave?
I think I think safety is most important, especially with these systems. And I would say, yeah, I mean, I'd have to learn a little bit more about kind of what I may be thinking in this industry. What I've learned is there's a lot of different terms for the same items, and I may know what you're talking about here, but I may call it something else. Does that make sense?
Absolutely. Yeah. There's fuse protection. There's the thermal boxes between your solar connector, and a lot of times when you have your MPPT or your string optimizer,
Yep.
things have a thermal runaway because they don't size it accordingly to the geospecs of the solstice cycle. And then when
Yep.
you have a thermal runaway issue, that's when this is a fire protection. And
Okay.
it sounds like it does drive your
I
key
would say
decision making for
yes.
those fire safety decisions.
Yep. We had on our inverters, we have a choice between I think it's either 24 non-fused or 36 fused inputs. So that does, I think I know exactly what you're talking about now.
Yeah, it's becomes an important thing for the DoD and also these community projects for thermal runaway protections into the string. The inverter can handle so much, but at the same time, it's just a few pennies on the dollar. Would you UL or AHJ the requirements to influence this?
Yeah,
Yeah, I think it's needed.
I think it's
Uh,
important.
it's
Sure.
important. Yeah. And moving into the energy storage, with integration of utility grid storage, it's the big play. And how are you currently approaching integrating energy storage systems for customer designs?
So for my experience with CPS, we actually we had an AC coupled system, which we can provide you with a whole system using those. We had a 250-800 and a 350-800 volt inverter. We also had a 250-600 volt inverter. But we also had a 200 kW PCS inverter, an inverter for energy storage systems. And we offered solutions as far as full solutions up to a 5 megawatt hour battery that were all AC coupled to provide the entire solution. We had a 2.5 megawatt PCS skid, which also had all the switch gear on it. So pretty much offered like a plug and play system. The nice thing about being AC coupled is that it's easier to add storage after the fact. So if you want to get your PV project up and running, you can do that. And then you want to add storage, down the road or, a little bit afterwards. What I've been told is that AC system, that coupling makes it a lot easier to do that. So we offered the full gamut, I guess you could say.
Okay. So 2.5 megawatts was your microgrid ESS bomb. It was on a skiff. It had these PCS one line block that did the power conversion at 200 kilowatt. I think they also had if I was talking with somebody correctly, they have a 1.2 megawatt option as
Yep.
well that they don't advertise. And when you
Yep.
look at the energy efficiency of looking at, building something in house, they just have it really form factored to grid scale. And it's at the COTS, it's turnkey. You know what you're getting out the box, and it's been utility grid ready for all these vertical ESS storage companies.
Yeah, I mean, it was everything was very customizable, depending on what you wanted. So yeah, if you wanted a little bit less, a little bit more, we can usually provide that for you. But it's a lot of, it's a lot of back and forth. It's a lot of engineering. It's a lot of, us talking to the customers, engineers, them coming back. We have a intake form, that has to get reviewed and signed off by engineering. You've got your configuration tool for your transformers and things like that for the solar project. So there's a lot of back and forth. I think one of the key things is how to speed up that process would help. Not even between just the customer and the vendor, but also out in the field as well with the interconnections and things like that. Speed wins, right? And right now, I think that process is a little slower than we want it to be. But
Yeah, it's all about your commissioning engineer who's fluent with the transformers, the interconnects, and the process behind the utility. And what are those red tape constraints? Trying to figure this out. The customers have come to me for a solution. Hey, we need to build these faster. They say, hey, this is the specs of the transformer. But then when you talk with engineering and the application engineers, they're still missing components there to be factored into the initial design before that's actually built and delivered and engineered. So these are some of the strategic issues to address in the future. I like your stance at the AC coupling versus DC coupling and adding storage later. There's advantages to the AC side for C&I projects. I see DC coupling as an advantage for residential on the smaller side. So there's always an apples to orange point of view between sizing out these systems appropriately and a strategic integration with clear approach. And with cost and manufacturing innovation coming back to America and looking at achieving batteries at less than 9 cents per watt for battery cells. Is that realistic or necessary for scaling domestic ESS manufacturing?
that sounds low. That cost sounds very low. I think that would be extremely. It sounds low to me.
Yeah, we're seeing battery packs today priced at a little bit above 8 cents per watt, and this is for the residential side of the house. So
Okay.
when we look at the Fluence guys, they're already pricing these ESS packs at 9 cents per watt at the cell level. So we're looking at the vertical supply chain. 9 cents per watt. Our LCOE is to get it down to 7 cents per watt. And it's not just being the cheapest, it's also being the next generation of technology that drives that cost. And also you're providing the added safety, the thermal runaway capabilities, the anode-free batteries, the sodium ion cells that are being integrated into the pack storage. These are being made in California today by Unigrid. So
Oh,
sodium
wow.
ion is coming with a vengeance. It now has the thermal runaway to compete with lithium iron phosphate. LFP cells have a 400% boost, but it's going to take a while before all solid state batteries are ready for prime time and commercialization.
Right. Yeah, I think cost. I think for the residential market, it's that's something that's talked about. I can say that on the CNI and utility side, um, I don't. Cost is really kind of the last thing that I talk about a lot. Obviously, it's something that's important, but I think it's more getting to know what the project is, what they're trying to accomplish. Figure out who's owning the property, who's operating it, and selling. With these specifically from solar and now storage. You have to have, I think, as a company, have to have case studies of where your projects are, where your products are, the efficiency of them, all your data on these projects. I think that's most important, so you can show the value. Um, you know, I've thrown numbers out to people, on these larger, 2.5, 5 MWh batteries, and they're, which in a price that I think is a little high, and they don't really bat an eye. And it's just, I think right now it's the issue with getting the batteries, and if you can get one that you need. I think that's more valuable than what the cost actually is.
Interesting
If that
perspective.
makes sense.
Yes.
Yeah, yeah. Even our CNI battery, which is a lot smaller, it's a 125 250 kW. Um, Even those, which is an all-in-one system, pretty cool. I think we talked about that one in Philly. Um, that's something that's actually starting to move a little bit. And they're stackable, but I think right now it's just more about procuring them and how you.
Absolutely. I think the whole hiccup between the trade policies, how the taxes are going to be carried over to the consumer. Is the consumer ready to pay? And then, today, because of the supply chains, predominantly batteries are manufactured in China. Would you support a US based foundry?
Yeah.
I think that's important today. People want to see this, that it takes time to convince the grid resilience and policy support as we transition to grid resilience. What would you think it takes to convince regulators, utilities, and government agencies to support a major leap in clean tech adoption, especially around all solid state battery technology? This is the future.
Yeah, I think it's more a lot about awareness. We go to so many trade shows and spend so much money, and we go in, and it's all the industry people, and you go in and listen to these talks, and they're talking about the technology and fire suppression systems and all these things, these great things that we're doing with batteries to increase safety. But I think there's just like a stigma out there of people just not wanting it. They see pictures of batteries burning on the internet and things like that, and they just think that that's kind of the norm. I think we've got a lot of great people. Like I know, for me, I've worked with, done events and supported the ICEA in Illinois chapter, and I know they have 30, 40 people that they're constantly going down to their state house and having conversation with legislators, and I think that's very so impactful. Same thing in Minnesota; they have a great team out there. We do it here in New Jersey. I think it's getting out, but also going to your local. Like I'm on our local land use board, and getting in and talking to them and the town council and getting those people on board, because a lot of people are old school. They don't adapt well to new technology, and I think that it's just more about we have these a lot of kids coming out of school these days that are so far ahead with technology than even I am, and getting their ideas and like I said, sharing it with a lot of the local decision makers.
Absolutely. I think that will help shape policy changes as well. How do you contribute to the grid resilience?
How am I contributing to the grid resilience? Um, I got into solar about 4 years ago. Came to out of the from the large diesel generator background, and it's been a lot more rewarding here in the clean tech space. Um, and I feel like with CPS, I've helped them grow from when I started we were 35, 40 people, and now we're a couple of years later we're up to over a little bit over 100. So getting those fresh new employees, getting them kind of excited about our culture and what we're doing to help change the grid, upgrade the grid. And how do you do it? You what's the fastest way to do it? It's solar, it's storage, it's the fastest, it's the cleanest, and it's the cheapest. And just kind of educating people on that, because a lot of people just don't know. A lot of people don't know. I know like CPS is number one market share in three-phase string inverters throughout the U.S. I still, on my travels, still meet people who don't know who we are, and that's why is that? It's because of education. It's because they just don't know who we are. We're not a company that uses a lot of distribution. We prefer to go B2B and have conversations like this directly with the customer. And I also think that helps making sure that the customer gets exactly what they need for their projects. When I talk to somebody, I don't want to just, I'm not just going to look at a project and give you a list of materials that you have to buy from us. Run the plans by our application engineering department. Have a couple sets of eyes look at them. Maybe you're missing something. Maybe there's a better solution. But the main takeaway from all of this is education. It's just educating people on these new technologies, and in turn will make our grid more resilient.
Looking at AI and a supply chain strategy, how do you see the U.S. leveraging domestic supply chains to support the ever-growing demand for AI-enabled data centers, especially in relation to energy infrastructure?
Yeah, I mean, we don't have enough power to support all these AI, data centers that want to come on board. I've seen them. I see them. I see plans for them all the time. Our headquarters is in Richardson, Texas, right outside of Dallas. Texas is a hotbed for these giant data centers, and I think the best solution for them are these virtual power plants. Getting their energy. Whether it's using solar, whether it's a combination of different items or energies, but to be able to fulfill the needs of these, AI data centers that I think we need here.
Yeah, the infrastructure gaps. What is your concerns, today?
What are my infrastructure concerns?
Yes, I think you're about to say
it. I think it's speed and availability is one of them.
Absolutely. Trying to get those products, get them on board, commission, and then how do you, pass go? The permitting process, it can be drawn out.
Right. So one thing I wanted to mention before is as far as interconnection delays is what I've learned, again, and I'm just the material, I'm the inverter guy, but there's a lot that go into these systems. I think some of my more successful customers have relationships with people who have great relationships with the cities, with the town, that I see some that can get some pushed through faster. So I think it's about kind of collaboration, knowing your market, knowing your go-to people, whether, like I was saying before, we have so many of these trade shows, in your local market. I prefer, RE Plus out in, were you out in Vegas?
I prefer the West Coast. Yeah, it seems like a better, warmer environment for business to flow.
but like those shows are so big, like it's kind of gets overwhelming. You're setting up so many meetings. If you go to a local one, like if you're doing a lot of work in Texas, go to the RE Plus Texas that's down there and talk to it's just, like I said, a smaller, kind of more intimate atmosphere. Look for energy, shows on the side. There's a lot of different groups that do a lot of different things. I just think sometimes the gap could be, a lot of times the gap is, I don't really know who to talk to, or I can't get to this person. Well, you have to build a network of people so that you can get to that person faster.
Absolutely. It's all about your vendor support.
Yeah.
They help you roll out and deploy these. Looking at AI software for PPA and VPP optimization, what role do you think AI-driven software innovations could play in improving the procurement and optimization of PPAs and VPPs?
Listen, we're just scratching the surface with this AI stuff. But I I think that if you're not using it, then you're behind. Um, do you know Tim Montague does the Clean Power Hour? He's out of Illinois. It's a podcast.
I
Are you
don't.
okay?
Send me the
I would
link. I'm
I,
happy to listen in because these
I would
podcasts
love
are
to.
informational.
Yeah, I would love to introduce you to him because he's a solar warrior, solar and wind, he's renewables, and he has kind of been a mentor of mine, so to speak, for the last couple of years. And he is kind of pivoted from always going to do a solar storage podcast, but a lot into AI now and getting C&I developers and construction companies to help them along with using AI to help them. So I think I would be interested to see what his response to you would be on that. I think that would be an awesome um, question to ask him. But I think these data centers, everything is going towards this. I know AI is such a big buzzword these days, but like I said, if you're not using it, or somebody, you have to have somebody in your company that's using it. If you guys are trying to build your brand and build things, but I think it's where we are today. It's not going anywhere, and we just kind of have to embrace it and use it for what it's worth.
Are you using any AI tools today, Eric?
Um, I use it all the time. I mean, not even just in home life, kids with homework, things like that. I get asked from my fifth or sixth grader, these questions all the time. I haven't been in fifth grade in a long time. What's the fastest way for me to help them out? I'll just ask Chat GPT. Things like that for speed to kind of help them along.
What features do you see as most valuable using AI for solar development?
Solar development. Um, I guess information. If you're doing development, you're the one on the ground in the ground, dealing with the municipalities, getting the word out there, talk to these business owners, um, just keep, whether it's helping to find different business owners, helping to find what structures would be a good candidate for a solar project. Um, Really, John, it's endless what you can when you can ask it to kind of help you with you're developing. You're a hunter. You're hunting projects. So whether it's car dealerships, whether it's churches, whether it's municipalities, um, see which ones are find out what's the lowest hanging fruit. And if AI can help you do that, I think that's a win-win.
I think it does. It opens up room for new players. You have companies like Open Solar and Aurora dominating the design industry as a service, that a base option to 3D model your future clients. But I also think that there's room for new growth where AI can intuitively take your Google address and then go ahead and walk your customer through the escrow process. What incentives can we pick up that are localized? What can we do to take a look at a design that looks aesthetic, and then walking them through? We don't need an Aurora, but the customer just needs to know what they're getting. And then AI is able to process that lead, and fundamentally we're educating our customers as we go along. So we look at the incentives, the savings, and then the optimization, and as you said in the beginning, the safety of that system. And then if we can relieve that interconnect issue with AI, it alleviates the cradle to grave process, similar to having a wireframe, how Sunrun was able to model their business and just take over the whole dominating industry.
Yep, totally. You're right.
I appreciate your time, Eric. It's been great conversating. This was a good discussion to talk about these future topics and also what is standing in the way of grid resilient and power optimization for the future of photovoltaics and energy storage systems. Thank you, sir. My
Thank
pleasure.
you. Appreciate it.